Welcome back. Session 4, part 3. And we are still discussing the definitions, terminologies. We are also trying to discuss the life cycle of data science projects. These are hopefully going to provide us with the groundwork, the foundational work for upcoming techniques and methodologies. So we need to know how the entire picture actually looks like. So let's take a look at the screen, the PowerPoint. We have discussed about data, information, knowledge, and wisdom in the past. Quite briefly, we have data that are going to be facts. This is from different sensors we have, either the human sensors or it's coming from instruments that we have installed across the globe. It could be medical or climate-based instruments. We will talk about them in a few slides, in one of the slides at least. But data is coming. Data is raw and is coming. And then we are going to capture the data and we are going to slowly build a pyramid of knowledge. It's a kind of when the baby is born initially, the baby doesn't even know what the face of the father and mother looks like, per the discussions we had a while back in session number 3, early session number 3. But slowly the baby is going to realize what the actual face with all the lines and details of the face of the father and mother is going to be, or are going to look like. And then facials and everything else, the memory is slowly building. That's going to be the knowledge. When the knowledge is built, the baby is no longer going to mistake the father's face with, or the mother face with some stranger face. So this is the way the knowledge is going to be in the process. So we have a data. With the help of the information, we are going to build the knowledge. And then from the knowledge, we are going to get to a stage where we are going to make decisions. So let's take a look at an example. Data, the weather is rainy. Okay. What part of the universe are you in? Is it north? Is it south? Is it equator? Is this supposed to be a lot of rain in that particular location you are in? No. The data is simple. It's just rainy. We didn't say anything else. There was no attachment. There was no context provided. We simply said that there is a rain coming in. Then we have an additional piece of information that is coming in, that is piece of data that is coming in. The temperature dropped 15 degrees and then it has started raining. Okay, so this is going to be helpful. This is going to tell us whether there is going to be, at some point down the road, future, not now. I'm just trying to help you to see what my mindset is leading me. And the mindset that I have is telling me that maybe the temperature drop had anything to do with raining. But we didn't make that decision yet. As I'm saying, I'm just trying to tickle you to the extent that to say, listen, there are some additional pieces of data coming in that could assist us to make the process meaningful, process more trustworthy. Knowledge, because of the high humidity and substantial reduction in temperature, the atmosphere is less likely to be able to hold the moisture, so it rains. This is coming from the past. We had this in our memory bank. This was a conclusion we made in similar situations in the past. Is it true now for this particular case, for this particular location? We have to see, we have to examine that. And wisdom, it rains because it rains. This includes an understanding of all interactions that happen between raining, evaporation, air current, temperature gradients, changes, and raining. Now, this may not be much, but at least we know that raining is a very complex phenomenon. And what happens is that at this time, when the next time the rain comes in, we will be looking at different parameters, variables that we need to make our judgment based on. So not only is going to be humidity, not only is going to be temperature, we are going to take a look at the pressure, we are going to look at the air pressure, air current, and basically whatever changes that are actually happening, including the geographic location of the place we are talking about. This is a process that I need you to keep in mind as we go to the next stage. Okay, What are the goals and scope? Well, there are many goals, quite a bit of scope involved. I just want to draw your attention to two of them. One of them is to act as in data scientist, and the other one is going to be a data engineer. Okay, so the data engineer is someone who already has the tools available and wants to engineer it, as simple as that. So it wants to build a platform where the data is going to be potentially streaming in a different way. Maybe they are looking for a specific patterns inside the data. The sources that the data are actually bringing in, managing them, integrating the different sources of data that are coming in. All of that is going to be part of the task for a data engineer. Basically, for the data science now, they are actually looking for new insights. As I said, they are scientists. Scientists means that they need to either look into the existing foundational work that they have done in their memory bank, in the wisdom that they have collected in the past, or they need to create a new insight. And that new insight becomes part of the memory bank, and that new insight is going to be part of the collection of the wisdom. Now, keep in mind that data engineer, and to some extent, needs to be a data scientist. So data scientist is the mother of all in that sense, I would say. So, but data engineer could potentially come in, modify the data, take a look at the variety of sources of the data, see whether they can basically integrate these and then make sense. So that's the data engineer tasks and duties. An interesting things that in terms of figures and facts might be slightly different from year to year, from basically decade to decade. If you take a look at this graph, you can see 60% in this presentation of the task of a data scientist is on cleaning the data. It's really messy. And as we are talking about huge data, big data that are coming at you, take a look at the amount of chats you have during the day, Reddit, Telegram, Instagram that you see, social nets, Facebook. Then take a look at so many hours of recordings that are posted on YouTube and elsewhere. Take a look at phone calls, audio signals that are happening across the globe. We have 8 billion people, and all of them are talking almost non-stop during the day. And as the volume and basically attributes of data, we will talk about volume and velocity and everything else later. Attributes of data is basically pointing us to a huge collection of data. Then the cleaning becomes even more significant. I would say that up to 80% of the task of a data scientist is going to be on cleaning. Let's be modest in this sense. Cleaning and organizing data is 60%. Training sets 3%. Mining data 9%. If you are well trained, if you are well rehearsed, mining data should be easy. But the problem is many programs written, as you will see in labs, are going to fail simply because the data is not clean. So you may have had the program ready, maybe you have grabbed it from an available free source, open source, and then you want to run it. The only problem is that the data you're running this on could potentially be a lot noisy. Take a look at your chats. How many acronyms you use? What kind of exclamations and question marks and everything else you use? All of that, do they have a meaning, or are they just noise and garbages that we need to remove? That's a big question mark. And then refining algorithms, obviously you may have to have some of the algorithms that are well established. You may have to hybridize 2 or 3 algorithms to make it better, and then eventually go for visualizations and show the results. Once again, this is about the pipeline. Keep in mind, collect the data, clean the data, find for the pattern, apply the algorithm, visualize, make recommendation, send it to the boss. So remember that this is a pipeline, and we are going to face that in almost the rest of this presentation. And now we get to the data science application. It's really integrated with our own life at the moment. This is just a snapshot of applications in the area of data science. We talk about e-commerce. Briefly, we talked about that in the past. We want to identify the customers. We want to see who might be interested in what. If you go to Amazon, there is going to be a recommendation system. You pick up a webcam and you can see that the microphone is offered to you. Different types of microphone is there. You could potentially have even the webcam. You could potentially be recommended different series of webcam just to entice you to choose one of them. So it is either in the same category or in the lateral category. We will talk about that later. And those are going to be the elements of the e-commerce. This is actually data science job, to provide the best recommendation system for the user of Amazon.com, for the user of BestBuy.com or Walmart.com. And then there are going to be reviews. A majority of them are going to be verified customers, verified purchasers, for example, in Amazon or some other sites. Some of the reviews are going to be just fake, and you need to be able to first screen them, identify the fake reviews, and after it's done, you need to take a look at the review and say, okay, what does this review mean? Does it mean that I can buy the product, or it means that this product is quite risky to buy? Maybe you want to buy an alternative, a product in the same category, but with a different company. It's e-commerce, so it's about buying and selling. When we get to the manufacturing, it's huge. You want to identify the anomalies in the manufacturing processes. You want to basically do predictive analytics and in terms of potentials that could exist down the line. You want to know whether maybe 2 years down the road, you may have to change the drill or some other pieces of equipment that is going to be wearing and tearing. Monitoring system, obviously, whenever you have data, whenever you monitor, you want to learn. You want to take a look at those monitoring information and say, okay, I think around 2 a.m. in the morning, 3 a.m. in the morning, something important is going to happen, perhaps for the system or that, and we need to be well aware of it. So as soon as you collect the data, you always want to learn from the data. You don't want to let it go. Whatever data you collect, whatever action a human being takes, a machine basically undertakes, that action is going to produce data. And that action needs to be monitored. And that action means we have to collect the data. And then as soon as you collect, the question is what this data is telling you. So that's what it is. Automating process. Of course, if you have learned the pros and cons of a specific technique, you would like to be able to automate the entire process. That's why we call upon artificial intelligence to help us. We call upon neural network to help us because we want to be able to automate the entire process. We want a robot, keep in mind, we want a computer, a robot, to actually replace human mind, human brain. I don't think it's going to be as simple as what I just said, but it's the right move in the right direction, okay? When we get to the banking, we talked about fraud as if using a credit card in San Francisco, in Mexico, in Paris. We talked about it in country X alert that is coming with the credit card agency. And then the credit card agency would like to actually rank me. Is this person high risk? Is this person always loses the credit card, always misplaces the credit card, has a strange habit of purchasing? What's it? And then if you are a loyal customer and you are here and you're enjoying the product of the company, you want to know, okay, how long this is going to last and what can you do to actually assist this customer? For example, the customer may have bought a mortgage to buy a house, may have undertaken a mortgage from a bank to buy a house. Is this customer, who is a well-paying person, make sure that all of the payments are done on time? How about a car loan? How about a refinance? How about a repair loan or whatever loan? I don't necessarily am familiar with all kinds of loans that they have, but they are interested. And as soon as they get to know you better through the machines, they can offer you those basically options and entice you to become more involved with them. The more you pay, the more they gain. As simple as that. Healthcare. There is no end into this. Healthcare. You want to take a look at the drug discovery. For example, the drug is usually is a combination of ingredients, and the idea is we have a disease X, illness Y, and we would like to see the effectiveness of the drug. So what you do, you're going to consider the hypotheses testing that we discussed in session number 3, and those are actually quite a pipeline of data science project. You could potentially take a look at medical images that are coming in, especially, for example, during COVID-19, you might be facing with, I don't know, 10 million, 20 million of people, they have x-rays, CT scan, and you want to be able to scan them as soon as possible without overloading the system and without overloading the nurses and the doctors. So what do? You want a computer to take care of much of the screening in the first place, initial screening at least at the first place, and then the expert come in, and instead of looking at 20 million x-rays, maybe they can only look at 100,000 x-rays. And you have so many experts and specialists, and that wouldn't be much of a problem to do so for the medical community. Transport, self-driving cars. Again, you are trying to take a look at the images coming in, satellite communication, the path finding, the route that the car is supposed to take from A to B, minimum route, minimum, basically optimum route in the sense of going through all of the necessary points at the same time, exhausting the least of the gas, which is going to be the cost. Sorry, not necessarily self-driving car in that sense, but self-driving cars that are actually driving upon the regular gas. But of course, we have electric cars, and we have electric cars with self-driving cars capabilities. And we are not worried about the gas as much, but we are worried about the battery, the charge that exists inside the battery. Anything, again, you go into finance, you want to discuss the customers, you want to do algorithmic trading, is extremely hot. It has been for the past 10 years or so. I think almost 20 years, I would say, where computers are supposed to trade on the market without the emotions involved. They are capable of screening stocks and acting upon little signals in the stock that humans cannot even match in terms of speed. At the same time, you want to understand which stock to invest in and which stock not to invest in, when to sell and when to buy if you are doing it algorithmic. Even the regular retail investors often actually use technical analysis and learn upon that technical analysis, and actually it has its own footprint that you can catch inside stock signals. All of that is data science projects. And this is just a snapshot. It goes on and on and on and on. Astronomy, in the field of astronomy, researchers are actually using AI to identify exoplanets. You see how crazy this is. It's really whatever you have in mind, as long as it is repeatable. Let me tell you an honest statement. If it is repeatable, the best thing to do is to replace human with the machine. That is exactly what's happening in manufacturing. That is exactly happening in many, many fields. As long as it is repeatable, or if it is brand new scenario that has minimum adjustment required, that takes you to safely to the route you need to go to, then you use data science and artificial intelligence and all that. But as soon as something more significant comes in, you need to do a lot of testing. You need to do a lot of testing, And that's part of what we explained in session number 3, just a small amount. Now, let's take a look at some examples. You might be surprised. Remember, I told you that, for example, your cousin, your peer has recommended that you take the program data science in institution X, and that's going to help you with your job finding. That's exactly what the data scientist is supposed to do in terms of recommending. So the recommendation system is not just to recommend movies to you. It's not to recommend stocks to you. It could be recommending many things, including which program do you want to take, which college do you want to go. Internet search. You might be surprised to know that if you go to google.ca.com, if you go to yahoo.com, yahoo.ca, if you go to any search engine, you're actually performing tasks. You are basically taking advantage of algorithms that have been designed by a data scientist behind the view. Internet search is actually a text mining tool to some extent, and or you go in and you have a chat bot and you start asking questions, and the chatbot is supposed to answer you back. Or you have a phone call, you pick up a phone, you call an organization, institution, and what happens is that that institution, the regular voice, a computer-generated voice, is going to listen to your question and directly to the appropriate department. To some extent, some of them are simple, but it could be getting quite complex, especially if the type of questions are quite complex. And as you can see, there is a lot of work to be done in that area still. As you know, some of the drugs and pills may work for somebody and may not work for some other person. In the personalized healthcare recommendation system, we need to actually tag the medication to a specific person based on whatever we know on the health history of that individual. This is personalized healthcare. It's extremely hot, very wide, and you could potentially enjoy diving in and assisting as a data scientist. We want to predict disease. Where is the spread coming in? Country X, country Y, country Z. And you could potentially say it's coming from country Z and spreading, and you could take a look at the search words of country Z, and then you come together and you say, oh, I think there is a kind of a disease spreading in country Z. The same thing could be true in some other areas. You take a look at the live feed of data that is coming in through agreements among the governments, and you take a look at that live feed of data, and you can say, okay, I think the people who are handling COVID-19 on country X, country Y, they are doing better. They are not doing as good. There is a new variation of COVID-19 is coming. So these are the things that the data scientist is supposed to handle. Write the algorithm, write the program according to an algorithm with the cleaning of the data, look at the data, make sense of the data, and make a judgment, and make a judgment at the end. You want to optimize the shipping route. Generally speaking, data, processing data is under the umbrella of optimization. Applied optimization, which was my main area of research, data analytics, data mining, all of that is under the optimization. One of the optimization is just you want to optimize the shipping routes in real time. Fraud and risk detection, we talked about it. Delivery, logistics, I don't think that's necessary. In terms of drug discovery with data science, you could potentially take a look at mutations and see whether the mutation is going to get stronger or weaker. Remember, a strong and weak are two terminologies, two words that we are going to translate them first to numbers and then take advantage of that with the data that is coming in to see whether the virus mutation is actually significant or not. Basically, predictive analytics in healthcare, we want to take a look at the historical data, whether it's going to be individual, whether it's going to be society-based. We are going to perform a lot of statistics, correlations, probability, and take a look and see whether any specific information is coming through the data. And then predict whether the disease is spreading, whether the disease is dying, predict whether the economy is going to come back, because COVID-19 is actually getting less and less significant as we speak. Maybe it's going to come back with a new variation, never know. Is there a new variation coming? We need to know. And then patient health. So this is in healthcare. It's really self-explanatory. You could potentially attach a smartwatch, take a look at the walking, running, jogging, heart temperatures, body temperatures, sorry, heartbeats, body temperatures, and everything else. And then make a judgment. Is this person doing enough activity to sustain a longer time, basically healthy life or not? Am I going to have a heart attack 2 years down the road? Am I prone to have a heart attack 5 years down the road? Am I going to have memory loss, things like that? So all of that actually are medical. We talked about the banking industry. We don't want to go into that detail. It's already self-explanatory. Basically, it could be real time, or it could be just predictive. Real time means I'm going to take a look at the data as it is coming and then make a decision. Predictive means I already have restful data. Restful, it's resting in my database. And I'm going to take a look at that restful data, my bank, my data bank. And I'm going to make a judgment for this particular customer or not. That's predictive. You use predictive. You could potentially use predictive as in restful data plus the real time. You could. But you need to have appropriate computing devices to be able to handle that. Memory is an issue. We will talk about a few things later down the road. There are some challenges. Not everything is rosy. You just need to be well aware of that. Data science application in agriculture. In the past, the farmer would put the finger in the air to see whether the direction of the wind is going to be the air blowing. Is it going to rain tomorrow morning? No knowledge of what happens tomorrow. That was 1,000 years ago. Now, a couple of decades ago, we did have some weather forecasts, for example, coming through radio stations and TV stations. Now you can take a look at your cell phone and you can real-time update yourself with the weather condition of any area, okay? Now with that in mind, if you're a farmer, you would like to monitor the humidity and the moisture inside the soil. You also want to take a look and see whether the soil is well fed or not. Is the soil in good condition? Are there any pests and weeds that we need to? Is there any disease that is coming into your field, the corn field, for example? So we could potentially utilize data science pipeline, deploy data science pipeline in agriculture, using a smartphone, using sensors spread across the field, using algorithms that are running on server, using real-time information, real-time data that is coming from weather stations and everything else. We could potentially make a judgment whether we need to have a concern about the drought. Is it too much humid? Is it too much moist in terms of water? What is it? Are we going to have the crops harvested in September, October, August timeline? So that's what we need to worry about, okay? Now, as I said, not everything is actually rosy. It's fantastic. It's exhilarating. It's exciting that we are on a path to more and more recovery. The concept of data science and its component has existed for many decades. A statistical analysis has been around for centuries, not just one, many centuries, I would say, 2 at least, right? And we are using it, utilizing it in data science. Then in terms of things have changed. If you take a look at the pipeline is talking about collecting the data. We could not collect the data 20 years ago, 30 years ago, as easily as we collect now. We didn't even have a smartphone at the time. We didn't even have phone at the time, a handheld phone at the time. I mean, 40 years ago, right? Only military had it, I think. So that's a big change. The point of data, the point of contact has facilitated a collection of the data. So that's the biggest change. That's why the word data science has become so hot these days. The second one is that many of the algorithms we had in the past potentially would have been running on a piece of a paper and a hand a century ago. Then we had computers that were about 30 years ago, something around that. We slowly started to even familiarize ourselves with the operating system and Microsoft and Excel sheet and Word document and everything else. We didn't have as much computing power at the time. And then it was very slow moving computers, but things have moved and have improved tremendously. Now we can do trillions over trillions of operations on a single processor in seconds or fraction of a second. We have powerful servers that actually can handle different tasks, huge tasks, simultaneously. Parallel computing has become part of the mainstream now. You could potentially have a laptop, even you as a regular listener of this clip, you could have a laptop which has 4 cores, 8 cores, 16 cores, 32 cores, provided that you can have parallel computing at the same time and deployed. That didn't exist in the past. Then in terms of visualization, we didn't even have proper visualization. We couldn't fathom as to what it is that we are seeing in the data. It was a piece of a paper. Now we can see everything clearly on the screen. And by the way, before I forget, please put the resolution of your YouTube to HD, high definition, to see all the details in my presentation. Things have changed. The reason it is hot now, although it existed a long time ago, because pieces of it existed in the past. A statistical analysis, sure. Correlation, I understand. Probability, yeah. But now with the advancement in the hardware and the software, we could potentially pull together the entire pipeline from data to processing to visualization and decision-making process. You could even take a look at the decision you're going to make and see how likely that decision is going to be true or false. Isn't that nice? Provided that the program has been written, tested, and deployed, you can do this on larger scale. In the past, perhaps barely you could collect the data inside a small store your grandfather had, your grandmother had. Now, you can actually collect the data across all of these stores of a chain company across the globe in seconds and analyze. So that's the beauty of data science. Don't get me wrong, data science is a very beautiful topic, but it doesn't come without challenges. And those challenges, as long as you're aware of, it's going to position you in the proper place to be aware of them, to respond to them whenever they happen, to take advanced action to prevent some of them from happening. This graph actually explains to some extent some of the challenges. One of them is obviously security and privacy. These days, your laptop can be hacked. It doesn't matter whether you're PC or Mac. Even recently, there was a news on Mac malware or something. I don't know what it was, but it was impacting 30,000 computers. Servers have been attacked. Bank databases have been attacked. Stock markets easy. Military, academic, university. Hacking has become a part of the ecosystem of life that we have, the advanced life we have with the computer assisting us. And obviously, when you collect the data, is this data a fake news or is it a trustworthy news? Is it coming from the source that you want to believe in and you want to take basically upon that? So you need to know whether the system is actually going to be at the point of contact. You could potentially be attacked and data is stolen. Your credit card information can be stolen. as easy as you put it inside a card reader. That card reader may be in an illegitimate card reader, depends on where you are, where you go, okay? Security and privacy is definitely one question, and as soon as you expand upon the point of contacts, point of entry, the data points, the more and more you have, the more and more this is going to be a concern. Did you take appropriate action to actually remedy the situation and make sure the data that is coming to you is going to be secured? And at the same time, privacy is a different one. Privacy means the data is correct, everything is fine, but I simply don't want anybody else to have access to my health data. I don't want anybody else to have access to my bank information. So the data is correct, everything is fine. It is secured, by the way, but I don't want people to peek into my camera and take a look at my house, inside my house, where I'm trying to be as comfortable as any person can be. So privacy means you want to have your privacy honored. And in that case, how do you intend to make that happen? This is a big challenge, extremely hot area, especially IoT, security and privacy. And you might as well want to take a look at that. Now, in terms of scaling, one of the challenges we have is that you may have a project basically successfully tested on one user. You might have tested on one store. You might have tested on one specific region. But then you want to scale this up. You want to move up and have basically same algorithm applied to regions that have different attributes. The population is different in terms of age, they are different in terms of distributions of gender, possibly different, in distributions of views are different. And you would like to apply your algorithm to different regions, Democrats, Republicans, and everything else, and be correct at the same time. Scaling is a big issue. You might be finding your algorithm is going to be successful in one small domain, but it may not be successful as you are scaling up, bringing in more and more data points, may not be scaling. Big data is going to have its own challenge very easily. The easiest challenge the big data is the storage. We will get to a stage where I'm going to explain to you how much information is coming from the internet, on YouTube, on an hourly basis, on chat. You would be surprised to know how many tweets come in and go, how many people enjoy Facebook and interact on Facebook and Messenger and all that. Email, oh, and this is big data. And they are, most of the time when we talk about big data, they are not just necessarily a friendly, nice, good-looking data. They are actually coming at you, voice and video and everything at once. And you need to analyze them at once. So one thing is for sure, the storage. You need to have the storage for this. The second thing is that your algorithm needs to be able to handle such a huge set of data. Many algorithms actually depends on whether it's basically developed specifically for that specification using a standalone C, C++ or any other basically effective language, or you're using Google Colab, or you're using Google Colab, or you're using Anaconda. These are going to have a lot of limitations in terms of memory. And the memory, Google Colab says 15 gigabytes. As a matter of fact, it's not going to be. You are going to see that Google Colab can easily give you trouble for a lot less memory issue. So we will see. Overfitting, oh dear. The word that everybody needs to watch for in the domain of data science is overfitting. Overfitting, let me give you an example. One example is that your father has been, or your mother has been successful in field X. Maybe both of them have been medical doctors, okay? Maybe both of them have been teachers, or maybe one of them has been teacher, the other one has been engineer, maybe, right? Now, here is the problem. Most of the time, dads and moms are going to actually recommend to their children to pick up their own profession because they have a lot of experience in that. they can share the wisdom with the children. And that's the main reason we would like to have our children pick up field of study and field of work similar to our own, so that we can be handy. We could be assistive at any moment. Okay, we face this problem before, here is the solution. Isn't that nice? So as fathers and mothers, we would like our children to follow our footsteps. And sometimes the children follow our footsteps and they fail. That is called overfitting. Why? Because I have been successful as a father and a mother. I have been successful in my field. And then I'm going to project that upon my child, and the child doesn't have the same roadmap as I did when I was a young kid. And therefore, the child is going to fail. Besides, the internal passion that they have may not be the same as I do. And that's a very key parameter many parents do not consider. The internal fire that exists in the kid's heart is not the same as the internal fire that exists in the father's and mother's heart. This is called overfitting. And when it fails, it costs hugely. So let's take a look at some of these. Take a look at the overfitting once again, and take a look at the right-hand side graph. If you take a look at the right-hand side graph, you can see that I have some blue dots and I have some red dots. And you can take a look at this green line, and the green line, as you can see, is trying to capture every possible red, and it's going to exclude, every possible blue, and it's going to exclude every possible red. Do you see what it is? You see, this one has been very persistent in terms of that I don't want to leave any blue behind, and I want to exclude every red. So that's called overfitting, which means it's like a polynomial. You want to make sure that the solution is perfect. It is perfect for the moment. It is perfect for the past. But I can tell you, when you make it that perfect, have you heard of the statement? They say it's too good to be true. It is really too good to be true for future, which means when it is so perfect in the past that you can easily actually match everything that you want to, you could potentially, as a matter of fact, most of the time you're going to fail in future. The accuracy and other metrics of success that are defined for future values are usually very bad when you do overfitting. So the question is this: us as parents, is it not easier for us to just share our experience with the children and then let the children select according to their information? They are going to come back, they are going to consult us, and we are going to provide them different point of view, and they go back, they talk to their peers, and they come back again. But at the same time, they come to a solution that seems to be quite effective for them. And they carry the responsibility, by the way, all the way as they go to the higher education or any career pathway for that matter. Now, if you take a look at this, I'm going to have a black line, a kind of a parabola. I'm going to capture 95%, maybe 98% of the blue dots. But I'm going to lose on this blue, on this blue, on this blue, and I'm going to lose on this blue. I'm not losing, I lost on this, I lost on this, but I didn't lose here. But you can see the majority of the blue is captured. Which one is simpler? The parabola, that is just a kind of a second degree parabola, or is it such a polynomial, maybe with a 10th degree, 20 degree, that is going to capture everything? As a matter of fact, the parabola has shown to be a lot more effective in future as well, which means failing is going to be part of the game anyway. But on what term, on what condition will the algorithm you wrote is going to fail? Overfitting is a very important concept, and if you ignore it, you will ignore it as in your peril. So you need to make sure that you're not going to ignore it. We have volumes and velocities of data coming in. Obviously, we need to be able to scale it and store it. I'm going to leave you review the slides, privacy and basically security. We spoke of that as well. Many of the cloud companies are trying to resolve both of these questions in terms of storage, in terms of security and privacy. They have dedicated algorithms in place where they could potentially secure and keep it private, and at the same time allow your servers, tons of servers, so that you can potentially do the task you do. For example, when we talk about Gmail, when we talk about Yahoo, I think Yahoo is a couple of gigabytes, if I'm not mistaken, 10, 15 gigabytes. Gmail is 10, 15 gigabytes, just a simple account. You could potentially pay $2.50 a month. You could get up to 100 gigabytes on monthly storage. Storage is not an issue for Google, Yahoo, and Amazon. Amazon Cloud is actually one of the best rated in the market. Google Cloud is also very good. There are many cloud companies that are offering you these services. So they have solved this problem of the storage and basically security and privacy, but overfitting is your job. Overfitting is your job. Cost of scale in terms of storage is okay, but in terms of scaling itself, it's your job. You need to take care of that, okay? So let's wait for the next session, and I will continue in this session number 4. Thank you very much.